All right, so we think the technological difficulties are solved, but if you're not, we can always submit it to CFail next year. All right. Now I have to advance slides. There we go. Okay. So we'll skip over this stuff, reduce the base case. All right, so yeah, so what do you say to people? Well, first you have a really awkward silence and they all leave, but if they come back and pester you about it, here's what you can say then. I think staring blankly at a wall, no computer to be found. 'Cause I'm a theoretician and my mind is the playground. But then the real world dumps my paper in my lap and asks, but can you implement this crap? Look, I don't know, how could I know? We lost constants like 14 papers ago. This construction's built from a history of leaving out the C. Use big O, use big O. Don't need constants anymore. Use big O, use big O. Pesky numbers you'll ignore. I don't care, 'cause this paradigm says it's fast enough. It's cool as long as it's poly time. It's funny how the limit makes everything seem small. Like physical restrictions, cost, energy, and all. It's time to see what I can do when I can send it to sticker with really obfuscation to you. When FE's fast, so when it's free. So free. So use big O. Is a log term bothering you? Put a tilde on the O, and the O goes to. In my let reviewers rage. You hold my protocols too slow for normal ops. The sum would die out long before its runtime ever stops. But though you claim it's not efficient at this crawl, we're asymptotic here. Your N is just too small. Use big O, use big O. And constant work is just small fry. Use big O, and then low order terms go by. I don't care, 'cause this paradigm says it's fast enough. It's cool as long as it's poly time. Thank you.
Keep it going. That was a great song. Yeah. I am as applied as they come, and I was rocking out to that song. That was fantastic. That's how good it was.
Yes.
Yeah, yep. Let's get rid of this stupid thing. It's really annoying me. These computers are pieces of shit.
Okay.
Yeah, all right.
All right, where are my slides? Yes.
They're here.
As for, yes. So, an announcement. Sorry, it's not that funny. It's serious. PKC, I know some people were curious. When is it? Where is it? So PKC next year is going to be in Atlanta, downtown Atlanta, from 7th to 10th of May. So we're working on the website, the submission deadline, what's important. So it's gonna be, we think, November 1st. Soon the website will appear. We're working on the PC and we'll post all the announcements officially, but you get to know firsthand. So myself and Vlad Kolesnikov are the program chairs, and we have wonderful general chairs, Joseph Jager and Daniel Genking. All of us, the team from the brand new, the Department of Georgia Tech, Department of Cybersecurity and Privacy. And we are hiring faculty and students and so forth. So it's a side note. So you will see the website. The best part, which I hope will make all of you submit your best papers. So Atlanta Aquarium, one of the largest aquariums in the world. It used to be the largest, and now we're still competing with some. So we're gonna have the conference dinner in the aquarium and with the private view of the beluga whale habitat. So how cool is that? So please submit your best papers, and yeah, thank you.
So I have another announcement. If you like Crypto 2022, then you're going to love Asia Crypt 2022, which is going to happen in Taipei, Taiwan, December 5 to 9. We already have a website, so please have a look. So Taiwan has beautiful beaches. I think more beautiful than the beaches here. We also have barbecue, Korean barbecue, for example. We have shrimp. And a lot of other good food. So additionally, if you like hiking, we have a lot of mountains to climb at the seaside or not at the seaside. So please come to Asia Crypt, December 5 to 9 in Taipei, Taiwan.
Okay, this is also an announcement. This is an affiliated event of Asia Crypto 2022. This workshop focus on theoretical quantum crypto. We have great PC members. So please submit your best shot to this workshop. And there is no formal proceeding of this workshop. So you can do simultaneous submission to this workshop. So please check it at the website for the detail. Thanks.
Hello, everyone. I'm Hassan. I'm a computer science PhD student at Purdue University. Today, in this talk, I'm going to talk about conditional encryption with the application of toward password typo correction. This is a joint work with my advisor, Jeremy Ablaki. So consider the password-based authentication schemes receive lots of incorrect login attempts. Some of them from the original user, some of them are from the adversary to try to extract the password of a legitimate user. But there are some servers try to track these incorrect login attempts and try to identify some of them are legitimate or not, try to make sure that some of them are correct and we can use them for future login. there is a naive solution. We can store all these incorrect login attempts in this server. But the thing is that in the future, data breach happens. So the adversary can look at the typos stored on the server and by simple doing some layering algorithms, try to extract the original password from them. So regarding to this issue, there is a cool trick which is introduced in CCS 2070 by Chatterjee et al., which is called tip-top. The idea is using public key cryptography. Each user is assigned a public key and a secret key. And we store the public key in the server and encrypt the secret key using the password extracted from the password. In future, when you log in with the typo, so the server will look at your public key, the user public key, and encrypt this password and store into the server and generate a waitlist for future computation. When the user uses its original password, we can extract the secret key and decrypt all these stored password ciphertext of the typo attempts, and then we can decide if we can add them for future login or not. So there is a specific issue in this type of solution. This is the things that we found at in the tip-top construction. So consider our user is a little bit hangover and doesn't know which server is interacting. So he tried to submit its password of the crypto server for the server is not crypto. So the access is rejected. So maybe he doesn't know. He tried to understand which is the password. Tried to send another password. The same rejection happens. So he gave up doing some such attempts. So he goes. But the thing is that in the server you can see the encryption of the other accounts password is encrypted in the server. So when in the early morning, in the next day, he's not hangover. He's going to log in with the original password, and so the server decrypt all these ciphertexts and realize the other password accounts. So this may cause some security issues. So what we do? So this is the main challenge. What we want is trying to avoid storing logging attempts of the password which are not the original typo. So we are trying to, so the thing is that we don't know what is the original password. So for this way, we introduce the notion of conditional encryption. The idea is that you have a ciphertext of an unknown message and a message in prime, which is payload, and the predicate defined. So the predicate basically says that if the distance of password 1 and 2 is close, we can extract the output of this predicate is 1. So based on the conditional encryption, we encrypt the payload, which is in prime, in such a way we can extract C prime. So the idea is that given the secret key, in the case that the predicate between M and M prime is satisfied, we can extract the message M prime. But in the case that this predicate is not satisfied, we cannot extract the original password. So the security implies that there is no leakage between M prime whenever even the adversary knows the secret key. So back to the problem. So we can replace the typical encryption scheme with the conditional encryption. So we will see that in this case, as the other passwords can't have a large distance from the original password, after the decryption, we cannot extract that password. So the decryption says completely irrelevant messages to the original message. So yeah, in this case, the adversary is no longer able to extract the message. So basically, we implement the conditional encryption using partially homomorphic encryption, and then there is a C++ library for that, and we use it to modify the previous tip-top to make sure that the resulting construct satisfy these predicates, which is the most common predicate. Thank you so much for attention, and of course, special thanks for my advisor, adversary typo, that simulate the rump session by shooting me with the RAF gun when I pass the timing. Sorry. Thank you.
Just in the PDF, so just advance the PDF, or to advance the PDF. Where? is it? Not that one. So, no, back to this one. Present, press forward.
Okay. Hello, I'm Young-sik Kim. Today I'm going to share the latest FSC implementation result. Recently, my colleague and I have been implemented the very deep CNN models up to 111 layers. This is my story. Okay. Okay, motivation is very simple. AI is nowadays very important, and security and privacy is one of the major concerns. Therefore, we are going to use that the polyhomotopy encryption to resolve this problem. That means that the server take the encrypted data and process it without decryption and produce the encrypted output. But most important problem is that the polyhomotopy encryption is too heavy. Therefore, previously, when you try to redesign the HE-friendly networks, that means that the activation functions are usually approximated with very low degree polynomial and only very shallow networks. But we try to choose the different approaches. That means that we are going to use that downloaded models from the internet. Therefore, we have to carefully design that the high degree approximation for the activation functions. We firstly implemented that the ResNet 20 first, but it showed that the very high latency and required many computational resources. That means that it takes 3 hours for one image inference with 64 thread CPU powers. Therefore, our main question is that it is nearly possible to evaluate deep CNN such as the ResNet 110 on polyhomotopy encryption environment. It was not yet implemented, and considering our previous result, it is too heavy, may not be possible. Therefore, we developed 3 ingredients. Firstly, we present the high precision CKK's bootstrapping to be able to compute arbitrary number of homotopy operations. Also, for the high-speed performance, we devised the multiplexed parallel convolutions to reduce the number of ciphertext itself generated during the operation. Therefore, as a result, we can achieve that more than 130 times better high-speed record. Also, when we first test the very deep CNN model, we realized that we find that there are too many garbage data are generated during the computation. Therefore, we have to take care of that. Then that is our result. When we only use that the single thread, we can achieve it. It takes that 2,200 seconds for the ResNet 20. It means that the 36 minutes for one image inference. And also, it takes that 13,000 for the ResNet 110 10 performance. Also, when we use that CPU parallelizations, that means that when we use the 50 thread at the same time, the amortized time show that 79 seconds for the ResNet 20 and the 455 seconds for the ResNet 110. When it comes to the classification accuracies, the encrypted data also show that almost the same result, same accuracy as the plain text. In this simulation, we only use that the CPU powers. There is no GPU, no ASIC hardware accelerators. Therefore, I can say that I can answer that the first question: is it really possible to evaluate the CNN such as the ResNet 110 on the fully homotopy encryption environment? my answer is yes. This is the reference, and you can find our source code on that URL. Thank you.
Thank you. Thank you. Hi. So nice seeing you all. My name is Bor and the new in Trondheim, and I'm going to be talking about my hot crypto summer. I don't know if the term hot crypto summer means anything to you. Well, it does to me. It's luckily also on the Urban Dictionary, actually. The hot crypto summer full of fun. Coach Mag says, hot girl summer is just about being you, having fun. It's turning up, driving the boat, and not giving a damn what nobody's saying. It's about a summer where you're in charge of your own happiness. That's where we are, right? That's where the community's at, actually. And my hot crypto summer has been great so far. You know, it started Eurocrypt Trondheim. Don't know, those who know, they know. It was great. Taking Amtrak here, actually also great, surprisingly. Shrimp, chocolate covered strawberries. I've been having a time. The hot crypto summer, I'm ready. Nothing could go wrong. Psych. Oh, wait, sorry. Psych. You know, we know where we are, right? We had the four NIST things, and then that's out. And I don't know how this is for you, but when it was like a few weeks ago and I was reading this news, part of me was like, oh, there's gonna be drama at crypto. And another part of me was like, there's gonna be drama at crypto. Because that's why we're here. And actually, we're not really a stranger to drama in the crypto community. I don't know if you're aware of this. I saw some emails recently. Here, this thing like, oh yeah, if you crack the ABC, yeah, you thought it was going to be something else, did you? Anyone who cracks the ABC thing will be given $400,000 bonus. And then Lawrence and Matthias, the madman, they were like, oh yeah, here it is, lol. Did you get the money, Lawrence? Did you get the money? No, they didn't get the money. But the drama didn't end there. I don't know. I recently, I don't know if you're familiar with this website, twitter.com. If you like crypto drama, this is where you go. Except if you go to the PQC forum, which is also generally, it's even better. It's similar, but with like the fewer hashtags and stuff. No, it's not been going that well. You could say with regards to the hot crypto summer, there was trouble in paradise. Or not, depending on what you like. There was someone else who said, we have some crypto drama where crypto means cryptography. This is kind of rare. There's someone else, I took this wildly out of context, so I've redacted the name, who said, given recent discussions on cryptography Twitter, I'm afraid crypto 2022 will be a shit show. Well, it's not that bad, luckily, but it made me think, it made me think about where we are as a community and as people with a common goal, because I was wondering, can we turn this into an opportunity for us? Because we're there, yeah, exactly, but you can also look at it in a positive way. There's something here, there's a place for something new here. Can we maybe make a new cryptographic primitive instead? What would the one-way function be? I know. I have a new PQC candidate. I hope the NIST guys are paying attention, and it is drama-based cryptography. Here we go. Here we go. This is the function. It takes a trivial input I, and then there's lots of stuff going on. And this will be called the fighting cryptographer's problem, FCP. And FCP has many amazing properties. Let's have a closer look, actually. Is it one way? Well, yes, it is. No way to understand what input has caused a certain result to appear. I'll do you one better, actually. It's actually better than one way, because most cryptographers will look at the output and they'll be like, no way, this is sick. You might wonder, is there forward secrecy? Well, yes, there is. Output is often random, even with identical input. And yet it keeps repeating. And you might wonder, does the FCP generate output efficiently? Sadly, it does. We've all found out. So it's great. This seminal work, of course, makes you wonder, is there really not a way to fight, to solve the fighting cryptographers problem? Is there really nothing? And this really, I've been thinking about this for a while, and I had a heart-to-heart with, some esteemed members of the community, and we talked about it, and we concluded that, well, yes, we can. We can solve the fighting cryptographers problem with constructive discussion by listening to each other, all of us as a community, and with mutual respect. In other words, not in sub-exponential time. I thank you very much.
Hello, everyone. I'm here to tell a fairy tale. This is based on joint work with Omkan and Yamakawa, titled as "A New Approach to Post-Quantum Non-Malleability." So let's begin the adventure. So one day, Alice is going for an auction, and the target is this watch. And as you can see, she really wants this watch because this is the watch. And the auctioneer starts by explaining the rules. So all the bidders commit to their price first. After this stage, the auctioneer announced the beginning of the decommitment stage. Whoever pays the highest price will get this watch. For example, in this case, Alice will get this watch. However, after appearing in so many crypto papers, Alice now is already a cryptographer. He quickly realized that this is not secure. Wait, this is unfair, says Alice. I can show a potential attack. For example, this cat, he can intercept my commitment and somehow play with it, molding it into some higher price, right? And actually, indeed, some of the commitment schemes are designed for this purpose, homomorphic commitment. So in this way, yeah, the cat will take the watch away. After thinking for a little while, the auctioneer said, okay, this makes sense. Do you have any suggestions? Because we care about customer security. I says, okay, it's simple, just use non-malleable commitment. And the auctioneer eventually agreed to adapt this strategy. Here comes the day of auction. Every party make their commitment using the non-malleable commitment scheme. However, surprisingly, when the decommit phase happens, Alice realized that the cat is performing exactly the same attack. So what's happening here? Eventually, this cat taking this watch away, and he tells Alice happily that, surprising, that is right. You aren't the only one who gets into Greece papers. You know who I am? I'm actually Schrödinger's cat. And that crazy guy has performed thousands of experiments on me. At this moment, I want to pause and to give you a warning, all of us love cats. So this kind of experiments should remain mental experiments forever. Let's continue. After those experiments, the cat said, eventually I can quantum power. Quantum, Alice, it's beyond your imagination. Okay. So when I was preparing the slides, I'm not sure if cat woman counts, but if you don't like that, you can imagine the amplitude for this term is 0. So let me tell you what's happening on the day of auction. Actually, on that day, the same auction is happening in multi-universe. And I intercept your commitment. And with the help of my colleagues in the multiple universes, I managed to perform the same attack. So learn your lesson, Alice. Classical non-malleable commitment may not be non-malleable anymore in the quantum setting. You can see that Alice is pretty upset and sitting there alone, crying, wondering what she could do. As we all know, Alice gets some good friends. And the Matt Hatter says, sorry, Alice, we are late, but we eventually get quantumly secure non-malleable commitments. That sounds interesting. However, I don't have quantum power. That's totally fine. To run our protocol on parties can be classical. That is what we call post-quantum protocol, says the White Queen. And Alice is not convinced yet. She said, but the auctioneer also cares about interaction complexity. That's also fine. Our protocol is constant run, says the Red Queen. Then what about assumptions? If you go as crazy as I.O., I don't think the auctioneer will buy it. Fortunately, we only need the minimal assumption of Moivre functions, of course, post-quantum Moivre functions. But auction already happened. I can do nothing about it. Here comes time. And he says, hey, I'm time. I can revert you back to the beginning of the auction. So you can finish the auction using this post-quantum non-malleable convenience. Eventually, they get Alice shut up. And as usual for fairy tales, a happy ending is where you stop. And I know that there are some parents in the audience, so I want to share this sentence with you. If you happen to have a daughter, if you want to give her a gift, there's nothing better than asking her to do quantum cryptography. If you are interested in how Alice's friends helped her to obtain this post-quantum non-malleable equipment, you can find more information at this link. Finally, I have a quiz for you. And if you happen to know the answer, go find Omkan. That's all I want to share. Thank you.
Hey, everybody. We're going to take another break now, a quick one. We're going to come back at 9:30. Let's clap again for all the speakers in this session.